Bismillahirrahmanirrahim. In this video, I discuss the topic parallel forces. What is mean by the parallel forces? Parallel force. First of all, we discuss about the definition. There, what is how we define the parallel force. Then the next will be the explanation, and the third one will be the mathematical form. First of all, we define about the definition. There, how we define the parallel forces. The parallel forces are such type of forces or their forces having the same direction but their magnitude may not be equal or may not be equal. Let's say if we have a force F1. Now the another force, if we take the F2, and this is 5 Newton. So, and this also equal to 5 Newton. So these two forces having the same direction and their magnitude is also same. So these forces are also called parallel forces, or these forces are also called equal forces. Equal forces. We have another term, equal forces. Equal forces are such type of forces in which the direction or this direction is same, but the magnitude must be the same. In equal forces, the magnitude must be the same, while in parallel force, the magnitude may or may not be same. So will be equal to 5 Newton or can be equal to 6 Newton, 7 Newton, 8 Newton. So these forces are parallel forces. Their direction is same, but their magnitude may or may not be equal to, may not be same. So that's why these forces are called parallel forces. Now, we have another term, and their term will be the opposite of this. That is called anti-parallel forces. Their forces are such type of forces in which the magnitude may or may not be equal and the direction are in opposite to each other. Let's say this is the force F1 and this magnitude will be equal to 6 Newton. Another force will be in opposite direction to this force, and that force is equal to F2 and that first magnitude will be equal to 8 Newton sodium. So these forces are anti-parallel forces. Now we taken the two forces. Let's suppose we have two forces applied on a table, and that forces are, let's suppose the first one force is represented by P while the second force is represented by Q. These two forces are applied at a point A. Let's suppose this is the point A, this is the point B. So as these two forces are in parallel, so the resultant will always lies in between these two forces. Because these two forces have the same direction, so that's why the resultant will lie in between these two forces. So first of all, as we know that the resultant is equal to Rx plus R1. Now for this we resolve this vector into its component like this. So this is the Py, this is the y component, this is the Rx, and this is the R. This is the Rx similarly, and this is the Q. So this is the R, Qy. This will be equal to Qy, and this is Px. And this is also Qx, and is the resultant. So if you resolve this vector further, now after proceeding this vector further, you get a cross point. So this is the point. At this point, the resultant will lie, and this resultant direction will be in this direction. So this is the resultant. Now to find the resultant magnitudes, we have, as we know that R is equal to Rxi plus Ryj. Now, first of all, we want to find the Rx. The Rx will be, as this Px is in the positive x direction and this Qx is in the negative q direction, in the negative x direction. So that's why we taken Px minus Qx. Here the Px is equal to F, while the Qs is also equal to F. Because both have the same magnitude, so the resultant will be equal to F minus F is equal to 0. Now we come to the y component of the resultant. Now the y component will be equal to, or y will be equal to the y component of Q and the y component of P, and this will be equal to Qy plus Py. Now putting the value of Rx and Ry in equation star, we get the resultant Qy plus Py I. So this is the equation, the vector equation of resultant. Now to find the magnitude of this resultant, we apply the magnitude criteria, and the magnitude criteria is equal to 0 whole square plus Qy plus Py whole square under the root. So it will be equal to Qy plus Py. So this is the final resultant of this one. So the resultant will be equal to the combination of y component of Q force and the y component of P force. Let's suppose this is 5 Newton and this is 6 Newton. So the resultant will be equal to 11 Newton. Now come toward the another topic, which is the anti-parallel forces. And anti-parallel forces, I already discussed that they are type of forces which have or had same magnitude but their direction are in opposite. So let's suppose we have a table. This is the table. One force is applied on this direction, and this is P. Another force is applied in this direction, and this is the Q. As these two forces are in opposite direction, so that's why these two forces are called anti-parallel forces, or unlike parallel forces. Now their mathematical derivation will be equal to, as if we resolve this vector into its components, so this will be equal to Py, this will be equal to Px. So this is the resultant Rx. This is the Qx, this is the Qy. So the resultant will be equal to R. Now proceed this vector further, you get a resultant, and that resultant will lie outside these two anti-parallel forces. As these forces are in anti-parallel direction, in opposite direction, so that's why the resultant will never lie in between these, but the resultant will lie outside these two forces. And if you proceed this vector further, so you get a resultant. Let's say this is the crossing point, so your resultant will be in this direction here. Now come toward the mathematical form. The mathematical form is R is equal to Rx plus Ry. Now the x component of this resultant is Px minus Qx, which are having same magnitude, so that's why their resultant component of in the x direction will be equal to 0. Now the resultant component of y will be equal to Ry, will be equal to, as this Py is in the positive y direction, this is the x dash, this is the y dash. These forces are in the positive y direction, so that's why we take this force first, and this force will be positive, so Py. Now this force Qy are in the opposite direction, y dash direction, and this y dash direction are always negative, so that's why we take this force negative. So we put the negative sign here, so it's the Ry will be equal to this. Now putting the value of Rx and Ry in this equation, so we get the resultant 0 I plus Py minus Qyj. So this is the resultant of these two anti-parallel forces. Now the magnitude will be equal to 0 square plus py minus qy whole square under the root. So it will be equal to py minus qy whole square under the root. So it will be equal to py minus qy under the root. So if we have this force, let's suppose this force is 10 Newton and this force is 5 Newton, so the resultant will be equal to 5 Newton in positive y direction. So the resultant will lie here in the positive y direction, because we get the positive sign with this. 10 minus 5 is equal to 5 Newton, positive 5 Newton, so that's why we take the in upward direction. Let's suppose this force is 5 Newton and this force is 10 Newton, so the resultant direction will be opposite, like this force is 5 Newton and this force is 10 Newton, so their magnitude will be minus 5. This represents the direction and this is the magnitude, so the magnitude of the resultant will be 5 Newton and their direction will be in the opposite direction, in the negative y axis direction. So this is all about the parallel forces and anti